So today we get into irrational numbers. So at the very top of page 402, down there at the bottom, 402, okay? So the definition's kind of funny to look at. A rational number is a number that's not rational. Well, yeah. So what is it? Well, it is basically any decimal that's non-repeating or non-terminating. So if you have a decimal like 7.2222222, that's a rational number because it repeats. But if you have a number like 7.23463 and it goes on and on and on and on and on, that's irrational. Also, non-perfect square roots and non-perfect cube roots fall under irrational numbers. Okay? So I think what does a better job of explaining it is this little Venn diagram here. Okay? So irrational can have their non-perfect square roots and cube roots, which you see some in here, right? That's a non-perfect square root. That's a non-perfect cube root, meaning that its roots aren't a whole number, right? Nice, easy positive or negative number. Okay, it's got decimals in it, and those don't repeat, don't terminate. The most popular one is pi. Okay, that is when you put that into your calculator. Again, these calculators round because it only holds so many decimal spots, but it goes on forever. Okay, if you look up pi on Google, you'll see like posters, and they go on and on and on. It never ends. Okay, so that's what anything else falls under rational, which you can see there are a lot of classifications in the rational part. Remember, we've talked about that, right? Natural numbers 1, 2, 3, 4, which are also part of whole numbers, but you add 0, which are also part of integers, which add negatives to it, which are also part of rational numbers, which adds fractions, terminating decimals, repeating decimals. So these are all, there's so many subsets of rational numbers. There's only one type of irrational number. All right. So this little chart here, if you look at it, kind of talks about it. Square root of 12, it's irrational because it's a non-perfect square root, right? It's between the square root of 9 and the square root of 16, which are perfect square roots, right? That's why I gave you that little cube thing to look at. You know, that little notes with squares and cubes. So that'll come in handy. All right. B, this is rational because 0.25 is a repeating decimal. 25, 25, 25. And anytime it repeats, it's rational. The negative square root of 9. That's not only rational, but it's an integer because when you take the square root of 9, it's 3, and you take the negative of that is negative 3, right? So it's an integer and it's rational. Okay? So take a look at number 1 in the try apart. Look at number 1. If you can't see it up here, look at your paper really close. What do you think that number is? Rational or irrational, and why? Irrational? Why, Justin? Yeah, if you look, it doesn't it has a pattern, but does it repeat? You know, there's a 1 and then only 1 2, and then a 1 and 2 2s, and then a 1 and 3 2s, and so on. So it has a pattern, but it's not a repeating decimal. Yes, this is irrational. Very good. What about number 2? Why is it rational, AJ? Well, it's not 13. It's up higher, one higher. 14, right? You take the negative, which is negative 14. So yeah, negative 14 is rational. What also is it? It's an integer. So remember, when it's rational, make sure you can classify them. Sometimes, let's say if they give you the number as 1, that's all 4. It's not only rational, it's an integer, it's a whole number, and it's a natural number. So it's all 4. Okay. Number 3, the cubic root of 2. Caleb. Why? You are right. Is this a perfect cube? No. Okay. So again, it just doesn't fall into the perfect cube, so it's irrational. All right. So again, just kind of getting to know the numbers, because now we're going to take it a step further. Now we're going to start kind of guessing where they kind of fall between, to the nearest integer and to the nearest tenth. Okay. So if you look at like that's one example here where they take the square root of 71. Okay. So you got to think of the perfect cubes, and they came up with 64 and 81 because 71 is between those numbers, right? And the square root of 64 is 8. The square root of 81 is 9. So you could put it on a number line. Sometimes people can just visualize it. But 71 now, you got to think, is it closer to 64 or 81? Yeah, it's only 7 away from 64. It's 10 away from 81. So it's not even really kind of halfway, right? So that's where when they rounded to the nearest whole number or integer, that's why they said it's kind of about 8. Then we take it a step further, we go to the nearest 10th. Well, you know it's kind of less than half, right? So you could start at, and they put some decimals in here. I showed first hour, which I thought was helpful. Use your calculator, start here in the middle. So like take 8.5, okay? Because that's literally right in the middle between 8 and 9, right? And square it. Well, when you square 8.5, it's 72.25. Is that bigger than this number? Yeah, so let's go down a tenth. 8.4 squared. 8.4 squared is 70.56. Is that still bigger than this number? No, we went past it, right? So the two numbers in our, if 8.5 squared is 72.56 and 8.4 squared is 72.25. Which number is the square root of 71 closer to? Is 71 closer to this number or this number? Yeah, it's closer to this number, right? So that's where they get the 8.4 from. It's closer to 8.4 than an 8.5. And that's how we can kind of use that to round up. So let's try one together down here. Okay. Square root of 8. We know that's not a perfect square, right? Think of the two perfect squares that the square root of 8 falls between. What two perfect squares does a square root of 8 fall between? And then what are the roots? Anyone got? Yeah, the square root of 9, right? Which is 3. The square root of 6, is that a perfect square? What's the other square root? Square root of 4, right? Which is 2, right? All right, so it's between these two, right? Now, is the square root of 8 close? Is 8 closer to 9 or 4? 9, right? So the square root of 8 is about 3. We do that little curvy equal sign because it's not exact. But we have to round to the nearest 10th, right? It's going to be closer to 3 than it is 2 because you can see that right there, right? Now, that's the integer, right? Now we got to figure out the nearest 10th. Well, we know it's only 1 away from 9, but it's 4 away from the 4, right? So we got to go past 2.5. Let's try 2.7 and square it. Well, 2.7 squared is 7.29. So if you took the square root of 7.29, you get 2.7. So we got to go a little further. Take 2.8 squared. 7.84. We're not quite there yet, right? 2.9 squared is 8.41. So we know that 2.8 squared is 8.41. And I'm sorry, that's 2.9 squared. And 2.8 squared is 7.84. So where does 8 fall between these? Is it closer to 2.8 or 2.9? Is 8 closer to this number or this number? What was it? It's only 0.16 away from this, right? It's 0.41 away from that. So it's closer to 2.8. So if we did a nearest decimal, it would be this guy. All right. So let's try another one. The negative of the square root of 13. Well, we know our answer will be 2 negative integers for the roots, but let's figure out what 2 square roots does 13 fall between. What 2 perfect square roots does a square root of 13 fall between? We kind of got started here, so just kind of take it a step further. 3 and 4, because what's 3 squared? Right, so if you did the negative square root of 9, that's negative 3. And then you said 4. So then that's the negative square root of 16, right? So it's between negative 3 and negative 4. Okay. Now, just kind of hide the negatives for a little bit. Is 13 closer to 16 or is it closer to 9? 16, right? So for the A part here, this would be about -4. Now we got to figure out decimal. Well, it's kind of, if it's 3 away from 1, 4 away, it's almost in the middle, right? So let's take -3.5 and square it. If you just put the negative in there, it'll square 3.5 and give you the negative. 3.5 squared. So that's -12.25. So we're still below 13. So let's go to 3.6 squared. It's 12.96, getting closer, right? -3.7 squared is -13.69. So we'll write it up here. So -3.6 squared, and again, if we'll make it negative, is this. And this is this. So where does 13 fall in there? What's it closer to? -13, by the way. What's it closer to? Is it closer to 12.96 or 13.69? Yeah, 12.96, right? So we would say this is about -3.6. And again, it's not asking for an accurate answer, right? Because it asked you to round, approximate. That means that's not an exact answer, right? All right, we'll skip 7, but I want you guys to try number 6. Try number 6. See if you can find A, the closest integer, and then B to the nearest 10th. Okay? You can work with your group. So try that one. Let's see how you do. We'll come right back. So what two integers of the roots did the negative square root of 24 fall between? Eighteen's a perfect square root. (25) and 16. Right? Which is -4 and -5. So if we were to make a number line, okay, and there's 4 there, where would the square root of 24, which is it closer to? Yeah, it's literally like right there, right? Because it's only 1 away from 25. It's not 8 away from 16. All right, so we know that A was about -5. So now for B, we're going to use our calculator. Well, if it's pretty close, let's just try -4.9. The negative of 4.9 squared is 24.01. That's a little bit bigger than 24, right? And if you did the negative of 4.8 squared, it's 23.04. Well, it's definitely closer to -4.9 than it is 4.8, right? It's a 100th away, where it's 96 hundredths away from the other one, 4.8. So this would be about -4.9. Very good. How many people got both of those? All right. Now for the next one, instead of putting these on number lines, we're going to just use the calculator. So which number is bigger, and explain why? Well, square root of 8 and pi. Everyone knows what pi is pretty much, right? If we were to take just kind of a roundabout decimal of pi, it's about what? 3.14, right? So do we think the square root of 8 is bigger than that or smaller than that? Smaller? Well, let's take the square root of 8, which is what? Yeah, remember, this is not a perfect square root. So this is a decimal that will go on and on. We're just going to round it to compare. It's about 2.8. So what's bigger? Yeah, pi is bigger. Just the decimal in the one spot makes it bigger. Okay? But it's a little bit more than 3/10 bigger than square root of 8. Now, before we even put number 9 in the calculator, what do you think is going to be bigger, the cubic root of 65 or the square root of 26? How many people think cubic root of 65? Just by first instincts. Okay, what about square root of 26? All right, so let's hit the math button. Number 4, cubic root, that's 65 is 4.02, just to give us a decimal. And what's the square root of 26? So yeah, those of you who thought square root of 26, it's by almost a whole unit bigger. Yeah, should have known that the square root of 25 is 5. You know it's a little bit bigger, so that was at least going to be a little bit bigger than 5. So once you figure out 65, which the cubic root of 64 is 4. So it was a little bigger than 4. All right, what about the last one? What's the square root of 2? 1.4-ish. So this is going to be negative 1.4. And the negative of the cube root of 10. Okay, which one's bigger? Why is the square root of negative that's well, yeah. The further away from 0 you get, the smaller the number. So that means this is bigger. Very good. All right. Last but not least, we're going to bring back, we've kind of done this already. I'm going to kind of show you a little bit better shortcut to this. So when we found the distance between 2 points, remember we showed you how to do the Pythagorean theorem, right? If you had this point, and they want you to find this diagonal, we could draw these 2 units, right? And use the Pythagorean theorem to solve. We also showed you the distance formula you could use for this. Well, instead of graphing it, you could do something a little easier because you always know when you're looking for the distance between the 2 points to the nearest 10, okay? And we can square root it. We're just going to solve for a square root. Look at the distance between the 2 x's, okay? Because that's the horizontal leg, and then we got the short leg, the vertical, y's. What's the distance from -3 to -2? If you're trying to visualize those 2 points in a number line, how far apart are they? 1 unit, right? So that'd be your 1 squared. And now look at the y's, from -1 to -2. That's also 1 unit. You're always going to find your c squared with this because that's the diagonal, the longest side, right? Well, you get 1 plus 1, right, when you square 1, which is 2. So c is, how do I get to c? What do we do? Who remembers this from the Pythagorean? We square root both sides, right? So you get the square root of -2, okay? And if you want to round it to the nearest 10th, go into your calculator and take the square root of 2. So it's like 1.41, so about 1.4. Try it with number 12. Maybe 12 is a little bit further apart. So what's the distance between 1 and 5? How many units? 4. And what about from -1 to 4? 5. So what's 4 squared? What's 5 squared? When you add them together, it's 41. Square root both sides. So you get the square root of 41, or about, it's a little bit bigger than 6, right? 6.40, so about 6.4 if we're going to the nearest 10. I want you to try to do 13. Yeah, if you get 13, you're going to get 14. Try 13. Try 13 and see how you do. So let's talk about it. What's the distance? Here, I'll do this one in black so you can see it. From 5 to 9. 4. And what's the distance from 4 to 8? Well, when you square 4, what do you get? Which is 32. So when you square root both sides, you get c equals the square root of 32, which is about, it's 5.6568. Well, when you round that to the nearest 10th, after the 6 is a 5, that makes the 6 a 7. So it's about 5.7. Don't forget your rounding rules. All right. So for today, the rest of the hour, which for you guys is 21 minutes, I'm going to have you work on the self-assessment, which is short. Okay. These problems here. And then there is a homework assignment. Okay. These 11 problems that you saw at the beginning when you walked in. And again, a lot of them are really, really short, like classifying rational, irrational. So some of them don't take very long. So we're going to go over both of these tomorrow and see how you do. We're not going to do the self-assessment today. We'll do that in tomorrow's video. No, we're going to have some homework. All right.